for that because I have to cover all the three things together. Okay. The third is statistical analysis, and it's important. Then I will explain ANOVA analysis. Now, ANOVA is one of the tests which is mostly performed by the statisticians. Like statisticians, not only of computer science domain, from medical domain, from management, from economist, in each and every field, statistical analysis has its importance, and we will see how statistical analysis helps the management people, economists to analyze the data and to give the output. Next, I will explain how ANOVA analysis is related to statistics as well as to the data scientist as well as to the machine learning engineers. The next, I will explain you what is feature importance, and I will demonstrate the feature importance and ANOVA analysis using two tools. One is SPSS. SPSS is a very famous tool. It is owned by IBM. So it's a statistical tool. Basically, SPSS is designed for the economist. It is not for the data mining purpose, but it performs the data mining. But still, it is basically designed for the economist, for mostly management people, economists, medical people are using SPSS to analyze their data, to understand their data. And next, Orange tool. Now, Orange tool is a data mining tool which is written in Python. And Orange tool is the open source tool. So SPSS is not an open source tool, while Orange is an open source tool. So anyone can download it and use it at once. While SPSS is owned by IBM. So you have to pay for it. There, I think it is about $99 per year. There is a subscription fee for it. So I will tell you the use of both the tools, how we can perform the same thing in both the tools, so that the audience who is not having the access to SPSS can use Orange data mining tool and play with the machine learning algorithms. Then I will tell you correlation by using a Pearson correlation coefficient. And finally, I will tell you how to perform a data machine learning in Orange data mining tool. So let's start with the basic terminologies. So the basic terminologies, like to understand how statistics, data science, and machine learning are coupled together. So there is a diagram here. You can see first comes maths and statistics. So statistics is what? Statistics is a branch of mathematics. It's all involved mathematics in the statistics. You know, from statistics, we have studied in 7th and 8th standard, or even 4th, mean, median, standard deviation. All these are the statistics, but these statistics are known as univariate analysis. Univariate analysis means it's of a single variable. We are obtaining the mean. Mean means we are obtaining the average of a series of numbers. Okay, so statistics is a discipline of mathematics concerned with the collection of data, analysis of data, interpretation, and visualization. Collection means you need a group of data to understand how the data is behaving in particular scenario. Analysis means you are finding some relationship between the data. Finding the relationship, and then interpretation, giving some conclusion on the data. Like these two variables are interrelated with each other. And finally, the visualization. Visualization means you are showing in terms of graphs, in terms of pictures. Okay, so I think we are going on the right path. Am I clear? So I should check the chat for this. Okay. So now, so the statistics is about the mathematics. Clear now? Now is data science. Now, what is data science? Now, data science is the study of data. Simple. Data science is a study of data. Now, what data? Cleaning the data. Now, what do you mean by data is impure? It's not cleaned. Like data cleaning means you have a data which has some missing values in it. You have a data where wrong data is there, or some like age. Suppose someone has entered the age 500. There can't be the age 500 age, because age is a, like everyone know, we have age we can keep from 0 to 100 or 120. We can't go up to 500. So like such type of data are misleading us. So to clear such misleading data, we have to clean the data. So there are various techniques for cleaning the data. Then processing the data. Processing means applying various techniques, applying various methods to analyze the data, to extract some useful information from the data. And finally, analyzing the raw data to get useful insights. So data science is dealing with data. Statistics is dealing with data. Now, what is machine learning? Now, machine learning is a branch of artificial intelligence, AI, that is used by data scientists to enable the machines to learn automatically from the past data. So for the data science, machine learning is required. So data science is dependent on machine learning techniques to give you the insights about the data. So statistics is the mathematics. So data science is a processing a data cleaning, getting useful insights from the data, and machine learning is the techniques. Machine learning are the group of techniques or methods by which we can analyze the data. So you can see all three things are interrelated with each other. So here in the broad, you can see yellow circle, that is maths and statistics. Then there is a blue one where there is the superset is artificial intelligence. Then subset of artificial intelligence is machine learning. Subset of machine learning is deep learning. And data science is the intermediate between artificial intelligence and statistics. So it is using both statistics as well as machine learning. Okay. So like these three are linked up like this. So machine learning techniques are used by the data scientist to get the useful insights about the data. Now, what are the various machine learning types? Now, see, if we want to study what is data science, so first we have to understand what are machine learning types. Now, basically, there are 4 types of machine learning. The first is supervised learning. Second is unsupervised learning. Third is semi-supervised. And last is reinforcement learning. Now, see, when I'm talking about machine learning types, now machine learning is an approach where we have group of algorithms. What are algorithms? Algorithms are the steps that we need to perform. So each and every algorithm is having works in some specific manner, and it requires some specific type of data. Each and every algorithm works in some specific manner and requires some specific type of data. So depending upon the requirement of the data, we are dividing the machine learning types into 4 categories. The first is supervised learning, and the opposite of supervised learning is unsupervised learning. So these two are interrelated with each other. So first, we will focus on this. Now, supervised learning means we have a data in a form of X and Y, a labeled data. Now, what is X? X are the features. Like in case of machine learning, we called X as features and Y as the output variable. Like X as a feature and Y as a output variable. So like in case of supervised learning algorithm, by using the X data, we are predicting the Y. So X are the set of features. Like for example, if I want to identify, suppose which type of fruit it is by the information. So I will say X feature, first I will give a color, I will give shape. So color and shape are the X and Y is the name of the fruit. So like if I'm saying color is red and shape is somewhat oval, or like some round, like we can say oval. So it's like a red fruit, which is oval. It's like an apple. Y will be apple. The next is we have brown. We have brown and we have oval or circle. Then it's a sphere, we can say. So it is a chiku. So like this. So X is what? The number of features from which you can identify the fruit, and Y is the fruit name. So in case of supervised learning, you require both. You require the name of the fruit also. You require the characteristics of the fruit also to identify. While in case of unsupervised, there will be no labels. Label means there will be no Y, there will be only X. You will be given color and you will be given shape. You will not be given which type of fruit it is. So your machine learning model, in case of unsupervised learning, will not be given the output value, will not be given the label. So this can be explained by this example. So this is an example of supervised learning. So here you can see this is a label data. We are having hexagon, square, and triangle. And also we are providing that this shape where there are 6 edges is known as hexagon, 3 edges is triangle, and 4 edges is square. So we are providing both the data also and the labels also. So such type of training is known as supervised training. By the name itself, we say supervised. Supervised means there is someone who is giving you suggestions. Like here, this is a supervisor who is telling you that 6 edges is hexagon, 3 edges is triangle, and 4 edges is square. Is it clear? Yes. Am I going fast? Audience, please. Am I going fast? Okay. Thank you. Okay, I'm going fast. Some are saying yes. So, okay, I will be slow. So we have a label data. Label data means we have a data. This is a data. Label data means we are providing the labels for it. We are providing the output variable also. So my axis, this is my X, and this is my Y. So this is a model. This is a machine learning model. So this is just a diagram. So I'm telling you, we are providing data as well as labels to the model. The model gets trained. After training the model, we want to predict. Now, during prediction, we will give only the test data. So my test data will not have labels. This is known as training data. This is known as training data. Label data plus labels are training data. In training data, we are providing both data as well as labels. We are providing X as well as Y. While in case of prediction, we are only providing the data to predict. We are only providing the data. This is my test data. So here I am giving 4 edges shape. So my machine learning model is already trained. My machine learning model is already know that this 4 edges shape is known as square. So it will give me square. So in prediction, output will be given by my model. That is my machine learning algorithm. Fine. So what we are doing, this is known as training process, where we are providing the data as well as labels. So X and Y. So this is known as training process, and the prediction, this is known as testing process. So whenever we are utilizing any machine learning algorithm, we have to divide the data into 2 sets, training set and testing set. Training set will be known to the model. Will be known to the model means model is using the training set to learn the data, to learn the information about the data. While test set is for the examination. Like for example, when in the classes, we are also given questions as well as answers. So supervisor, the teacher will teach us, will tell us this is the question and this is the answer for it. While during examination, only the question is given to us. We have to predict the answer. So similarly, supervised learning works. So this part is the classroom teaching and this part is your examination. Okay, so this is the supervised learning. Right? Now, other than supervised learning, we have unsupervised learning where there are no labels. These are not given. Only you are given the label data. Now, how the model will know that this 4 edges is a square? Model will not know that this 4 edges is a square, but model will know that these 2 shapes, 1, 2, and 3, these 3 shapes are having same structure. So they will group them into similar. They will form one group of 3 squares. Then again, the model will check that these 3 are having the similar shape. So they will form the other group. So there will be group 1, there will be group 2, in which there will be 3 squares. There will be group 1 in which there will be 3 hexagons, and group 3, there will be 3 triangles. So in case of unsupervised learning, there will be groupings. So here we will get 3 groupings. So how the unsupervised learning works? In unsupervised learning, the model will learn that the 4 edges shape should be grouped together, should be made into one collection. So they don't know whether it is square, triangle, or hexagon, but they know that they are having a same shape. So depending upon the same characteristics of the data, in unsupervised learning, they will group together. I hope you understood now what is supervised and unsupervised. So now I'm moving to semi-supervised. Now, from here, you can understand that semi-supervised means some labeled data and mostly unlabeled data. Now here we have some labeled data. Half of the data is having labels and half of the data is unlabeled. So this is known as unsupervised learning. And finally, the reinforcement learning. The best example of reinforcement learning is the AlphaGo game. So AlphaGo game, computer playing chess. So how the reinforcement learning works? The reinforcement learning works by decision process, by giving reward system and punishment system. Like there is an example here I will show you. This is the example of reinforcement learning. Now here we are providing a data. So whatever data we are providing to the agent. So we want to create an ML algorithm. So agent is my ML algorithm and how agent will learn. So whatever data we are providing to the agent have fixed sets of state and rewards. Okay. So what will happen? Initially, when the agent will start learning the data, it will be at state 0. It will be at state 0. Now, agent will perform some action. Like in case of starting, if I am playing chess. So how I will start? I will start from, I will play. Okay. I will perform some action. So depending upon my action, the other party, the opposition team will take some action. Now, depending upon my action, either I will be given a reward or I will be given a punishment. So if my action is correct, I will be given a reward. If my action is like if I perform the correct action, I will be given reward and I will be forwarded into the +1 state, like ST +1. I will move into the next state. Okay. While in case of if I am done something wrong, if I am not perform a good action, it's wrong, then I will get punished and I will move to the previous state. So this process goes on. So we are not focusing on reinforcement learning right now because it is a very advanced topic of machine learning and AI. So I don't want to focus much more, but to understand the types, just I want to say that reinforcement learning works only on reward and punishment basis. And the best example is AlphaGo game. It is on reinforcement learning, playing chess game. Computer is playing chess game. Robotics, how robots learn. They learn by reward and punishment. So this is what the structure of reinforcement learning is. So here we have understood what are the 4 types of machine learning. And even now there is transfer learning, there is deep learning. We will not go into those. Actually, those are the subsets of machine learning only. But these are the 4 basic types. Now, like in supervised learning, the algorithms are classified into classification or regression. Now, depending upon what the output variable is, depending upon y. If your y is a categorical variable, categorical means it has categories like flower names, like fruit names. So these are categories. If your y output variable is a categorical variable, categorical means you have a set of, you can define a particular set. It is not infinite. It is a definite. Okay. If it is definite and if you can provide a set for y, then we can perform classification. While in case of y is a numerical value, then it's a regression problem. Like for example, classifying whether the email is spam or not. So this problem is known as classification problem. While predicting the house price, predicting the house price or car price or depreciation cost of laptop or anything, all those things will come under regression problem. So when your y variable, output variable is categorical, you can have a definite number, then it's a classification problem. Else, if it is a numerical value, like price, then it can be regression problem. So this was a brief introduction about machine learning types. Now we are moving to a statistical analysis. Now, what is statistical analysis and how to perform it? So first thing, I have some questions. Let me check it out. Data science, bias error. Oh, see, actually, I got some questions. I will answer it afterwards, after the session, because if I will go to answer the questions, so we will miss the session. So let's complete the session. You note down your questions. Then I will answer one by one after we complete the session. Okay. So statistical analysis. Now see, actually I am telling you statistical analysis is a very broad term. It is not only performed by the computer science people. It is not only performed by the machine learning engineers. It is performed by each and everyone today. Management projects, all the management projects, even of the master's level, require statistical analysis. Even the companies which are in financial domain, which are in marketing domain, they require statistical analysis. Even the economist, economic people, history people, they use statistical analysis. They don't know what ANOVA means. They don't know how they work, what is machine learning, but they are using statistical analysis. So each and every, whenever there is a data, there will be the need for statistical analysis. And today, you know, we are using lots of data is generated. Lots and lots of data is generated daily on Google, on YouTube, in a form of videos, in a form of images. So like there is no end to it. So data is considered as a fuel today. Today, data is considered as a fuel, and machine learning is a very powerful tool which is analyzing the data. So that's why today statistical analysis has got much importance in each and every field. Even medical people are using statistical analysis to predict the survival. They do the survival analysis, whether the person will die or not due to these symptoms. So all these analysis can be performed by statistical analysis. Now see, like statistical analysis, there are various ways how statistical analysis is connected with machine learning. Now I will talk about both machine learning as well as statistical analysis. Now first, I'm talking about ANOVA test. What is ANOVA test? So see, here I will not explain, today I will not explain you mathematics about ANOVA. If I'm going to explain you the mathematics behind ANOVA, so it will take 1 hour. Today just I have to give you the brief introduction. So I will explain you the theory, and I will explain you the hands-on session, how you can perform statistical analysis and how you can understand the output. That is my goal. So I have written some feature importance. Now I have told you that machine learning requires data, X and Y. So feature, we are calling X as a features. So whatever the characteristics of the data are, those are known as features. Now we have thousands of features to analyze. See, in case of machine learning algorithms, we don't have data in terms of like, we don't have 10 features. We have thousands of features. We have like 10,000s of features. You cannot analyze each and every feature. So what you have to do, you have to select some good features which are important for your analysis. Okay. So here I am performing the ANOVA test for feature importance. There are various ways to do the feature importance. So one is ANOVA test. So ANOVA test is used for hypothesis testing. So you know hypotheses, like if you know what is statistics, you know what is hypothesis. So hypothesis is a statement that we are making. Like we are saying that hypothesis is this particular group is good. So this is the hypothesis. We are making some statement. Some statement is known as hypothesis. So I will tell you how practically we are doing and what is hypothesis and all. So first, understand what is ANOVA test. So ANOVA is known as analysis of variance. Now, variance means what we can understand by the literature meaning of variance. Variance means the changes in the data, not changes, how different the data is with each other. How different the data is within a particular group or with the other features. How one feature is different from another. How the data in one feature is different from each other. Okay, so what we are analyzing by ANOVA test, in ANOVA we are analyzing that within one feature, how the data is distributed. How the data is distributed. Okay, so it will give you the variance. It will give you the analysis of variance. So it is a statistical technique. Also, it's known as a machine learning technique that is used to check if the means of two or more groups, the means means average of two or more groups are significantly different from each other. Like if you want to check how two features are correlated with each other or not. So if you want to check one feature is correlated with another feature, you can perform ANOVA test. By this theory, you will not understand anything, but I have to tell you, then I will move to the practical session so you will understand. I have a data set with me. I will explain you everything in detail. So ANOVA checks the impact of one or more factors by comparing the means of different samples. So let's skip to the theory. Just I will move to the directly to the example. Then I will come back to the F statistics. So now I have now we are performing the hypothesis testing. Now, in case of statistics, we called it as hypothesis testing. In case of machine learning, we called as a feature selection. Okay. Now, this output, which I have shown here, this output is generated through SPSS. So I will show you both. I will show you with orange as well as with SPSS. So now my hypothesis, I have a data set. My data set I am using is of, this is my SPSS. Okay. So as soon as you like open the SPSS, you will get this window. Now I am moving to the hands-on session. So this is the SPSS statistics, IBM. It's owned by IBM. It is not freely available. You have to pay for it, while orange is the freely available tool. So I am explaining you statistics through SPSS. The reason is SPSS is a statistical software. It's basically designed for the statistics. That's why we get very good results here. So for understanding, I'm using this. So now I'm taking one data set. So I'm clicking here, new data set. How to do? I'm telling you, new data set. And I got one file. As soon as I clicked on new data set, I got this file. Okay. So now here I want to upload my data. So if you want to upload your data, you go in file, read text data. So text data can be in the form of TXT, CSV file, any tag or DAT file. So already I have one heart disease data set. So here is my heart.csv. I will explain you. This heart.csv data set, I have downloaded it from UCI repository. UCI is the very famous machine learning repository. From that, you can download this data. So this is of the heart disease data set. Depending upon the number of features, you are predicting whether a patient will get heart disease or not. So this is the data. So just here, SPSS will ask you a few questions to load the data. Does your text file matches the predefined format? So we are saying no, go next. Then are variable names included at the top of your file? Yes, it is included. Age, sex, CP, cholesterol, REST ECG, Thalash. The names of the features are included. So we will say yes, it is included. And how it is separated? It is separated by delimiter. So it is separated. It is my comma separated file. It is a CSV file. CSV file is a comma separated file. That's why it is delimited. So I am clicking on delimited and I'm saying next. Okay. Now you're saying the first piece of data begins on which line? Line 2. The first line is my column name. Second is from second, the data is there. So I'm writing 2 here. It's already taking, it's automatically done. I want to take all the cases. So I'm taking all the cases and I'm saying next. And finally, it's asking which delimiter appears between variables. So it is comma. Yes, it's a comma separated file. And finally, it's variable name is age. Okay. So it's CP numeric next. Yes. And finally, this is finished. So it's saying, do you want to paste the syntax? Do you want to save it for the So I don't want to do it. This I'm saying finish. So here, this comes my data. So this is my data set. So my data set consists of features. These are X, X1, X2, X3, age of the patient, sex of the patient, like male or female. Then CP is some medical like analysis they are doing. Then press BPS, then cholesterol value, then FPS, rest ECG. So these are all the features. Till we have till thel, these are features, and target is my target variable, whether the person is having heart disease or not. So 1 is having heart disease and 0 is not having heart disease. So we are having two categories in case of target variable. One is heart disease and second is 0, no heart disease. Okay. So this is the data set. These are all X values and this is my Y value. Now we are having X value and we are having Y value. So this is the problem of classification. This is the problem of classification. And it is a problem of supervised learning because we are providing X to the machine learning algorithms. We are providing Y to the machine learning algorithm. That's why it's a problem of supervised learning. And in supervised learning, my Y variable is not numerical. It is categorical, 1 and 0. It is having two categories, heart disease and no heart disease. So heart disease is represented by 1. No heart disease is represented by 0. So we are having categories. So it is a classification problem. Okay. Now how to analyze this data in case of SPSS. So to perform the ANOVA test, you have to go in analyze. Okay. Now to perform the ANOVA test, now let's move to the slides first to explain you the problem. Then we will see how to perform the analysis. Now here we say that now in ANOVA, we want to calculate whether the age. Now first I'm targeting the age feature. So my null hypothesis. This is my null hypothesis. And this is my alternate hypothesis. So my null hypothesis is that age has low variance. Age has low variance. There's no impact on target variable. Now, if age has low variance, there is low variation in the age feature, then it is of no use to the machine learning algorithm. It is of no use to the machine learning algorithm for predicting the target variable. See, if your feature is having low variance, there is less variation in the values of the age, then such feature is not important to the machine learning algorithm. While if the feature is having high variance, it has huge impact on target variable. Huge impact on target variable means it will create, if you are choosing this variable for training the machine learning algorithm, then it will create a good impact. It will give you better results. Okay. So now see, low variance means if you are having low variance feature, so such feature is not important for the machine learning algorithms for training. While if the feature is having high variance, it will have more importance during training. Okay. Now ANOVA test. ANOVA test is used as a feature importance in case of machine learning algorithms, while ANOVA test is used as a like statistical. It can be used as it is used for the statistical analysis in case of statistics for hypothesis testing. So we have two hypotheses. Now when we are performing the hypothesis testing, we have to reject one hypothesis and accept one. Okay. Now by performing coming back to the SPSS. Okay. Now we are analyzing. To analyze, we are going into the analyze. Here we want to perform linear model, compare means, descriptive statistics. No, there is correlate. It's like compare means. Okay. So analyze, compare means. And here you have one-way ANOVA. There are various tests. There is a t-test also for this, but we are using ANOVA. Okay. So analyze, compare means one-way ANOVA. When you click here, they will ask you which two variables you want to compare the variance. Now I want to compare the variance of age. So I will enter into the dependent variable and I want to compare with the target. Okay. I will compare two. Or if we want to compare only one, we will say age. Only I want to see how age, because we are here testing only age. Here we are concerned about age only. My first hypothesis one is concerned about age feature. So I will perform the ANOVA analysis on age only. Okay. So here we are considering dependent list as age, and I will say age. So in contrast, you have to select polynomial degree. You're saying linear. Okay. So these are the settings that we can perform. So age polynomial, continue. And how we are analyzing with respect to target. Okay. So here we have options. Why it's okay is not coming. So contrast, polynomial, coefficient we have to keep. No, I don't want to add any coefficients. I don't want to do anything. Oh, please. Age. I don't know why it's not coming the option. Okay. Okay. Just a minute. I will do it again. Cancel. It's hanged. Okay. So once you do. Okay, back to the slides. I don't want to waste the time. So once you click on the OK, after clicking on age on ANOVA, you will get this table. So that's why I've already kept the output with me to explain you. You will get this table. Now see, like behind how ANOVA is performed. ANOVA is performed by using the mathematics. There are a lot of formulas, mathematics. So we are interested in this F statistics. Now what is this F statistics is? So this F statistic is the statistic which measures if the means of different samples are significantly different or not is called as F ratio. So F ratio will tell you the means of samples inside a single feature are different or not. So if you have lower the F ratio, more similar are the sample means. If the F ratio is low, then there is more similarity in the sample means. In that case, we cannot reject the null hypothesis. Okay. So here, this is the F statistics. So we have to check. We are interested in this F statistics and this significance. Okay. Now here, again, we will go back. Okay, analyze. Compare means. One way ANOVA. Find. Dependent list is contrast is no. Continue. Variance. Okay, significance level we have kept at 0.05. I will tell you what's that. I don't know why it's not giving me the option today. Statistics. Okay. Descriptive. Okay. Continue. Factor. Okay, I have to select the factor over. So that's my target. With respect to target, I want to do. Okay, so I'm selecting the factor as with respect to target. So I will say now, okay. So it is giving me of 2, sex and age. I have select 2. Okay, but we are interested in age only. So this is my descriptive statistics. So this is for age and this is for sex. Just a minute. Okay. Now here we are. This is the descriptive statistics where they will give you number of values in age. What is the mean value? What is standard deviation for 0 for target variable 0 and 1? Then what is a standard error, lower bound, upper bound, minimum, maximum. This is the complete descriptive. And this is the ANOVA analysis. So for my ANOVA, I am interested in this F measure. So my hypothesis is concerned with age, and I am having this F statistics. My F statistic is 16.117. Okay. Now this value is not low. It is low. Actually, it is generally it is in 3 digits. It is in 0 digit. Depends. So here we are having 16. So here significance is given. Now F statistics will determine whether we have to accept this hypothesis or not. But if significance is given, F statistics will give us the importance. So importance of this age feature in the machine for predicting the heart disease is 16.117, while significance is 0.000. Significance means it's 0. So it means that it has no significance. Okay. So now how to check this? So there is a thumb rule for hypothesis testing. So if you want to accept the null hypothesis, you have this rule. If the p-value, significance is p-value. So this is known as p-value. If the p-value, that is significance, is greater than 0.05, then accept the null hypothesis, else reject. So what you have to do? Now you check. Your significance is 0. So which is less than 0.05. So we are rejecting the null hypothesis. Like here, we are not accepting, we are rejecting the null hypothesis. So here we say that H0 is rejected. Hence, H has impact on target variable. So here, H has low variance and has no impact on target variable, we are saying. So we are rejecting this hypothesis with low variance. We are accepting this H1 hypothesis, alternate hypothesis, and we are saying that age has high variance, thus have a huge impact on target variable. Okay. Now, from this analysis, what we have done, we have understood the importance of feature age in predicting the heart disease. Is it clear? Okay. So this was the one hypothesis. Second hypothesis, I have taken cholesterol. So whether cholesterol is having the, so same, we have two hypotheses, null hypothesis and alternate hypothesis. So cholesterol has low variance, there's no impact on target variable. Now here you can see the significance is 0.139. When you're performing the ANOVA analysis, so if you want for cholesterol, you have to again go in analyze. Again, you have to compare means, one-way ANOVA analysis. Now I have to go this back. I have to select cholesterol from here. Okay. So I've selected cholesterol and I'm saying, okay. So I got the ANOVA for cholesterol. The significance is 0.139. Now this significance 0.139 is greater than 0.05. That's why we will accept this hypothesis that cholesterol has low variance and hence cholesterol has no impact on target variable. Okay. So from this ANOVA analysis, you can understand which feature is more important, and then you can select those features for the machine learning algorithm. So by using statistical analysis, you can accept the feature which is more important and reject the feature which is less important, and you can remove those features which are less important and only select the features, important features, and provide it to the machine learning algorithm for training. So what will happen here? This will increase your accuracy. Machine learning accuracy will get increased. Okay. So here we have performed the ANOVA analysis. Now, this is the orange data mining tool. Now, how to perform in the orange data mining tool? So this is the orange data mining tool. Okay. So now in orange data mining tool, as soon as you open, you will get this window. Now here, welcome to orange. So you have to click on new. We want to take a new file. So it will take a time. It takes time to load. Okay, it's came to. Now here you have to upload your file, that is heart disease. So already my heart disease.csv is already there. Otherwise, you have to browse through your computer and select those files. Heart disease. Okay, so it will show you what are the features here. Again, like it will show you how many instances are there. So the orange tool is very advanced as compared to SPSS. In case of machine learning, in case of applying the machine learning algorithms. So here we have age, sex, that already we have. And this is my target variable, that is whether the patient is having heart disease or not, 0 and 1 values. Okay. Now, here also I am performing ANOVA analysis. How to perform ANOVA analysis here? By feature importance. So here you have rank. Rank is for ranking the features. Now, if you will click here, now one thing, now in this data set, there are few categorical features. So if you have categorical features, Orange tool will not provide ANOVA analysis. That's why what we will do, we will select only those columns. We will select only those columns which are numerical. To select the columns, we have a select column widget here. So I am taking the widget select column and I am selecting only the features which are numerical. So 3 features are ignored and all the numerical features are selected. You have to select from here. Like if you want to move you. So I want to filter this. I want to filter categorical features. So I will select and I will move it here. Okay. So all these 3 categorical features will be removed. Now I am providing this to the rank. Now here rank is providing me the feature importance. Which feature is more important? This is the ANOVA analysis. Here there are many scoring methods available in Orange tool. RELF, X square, Gini, then information gain ratio, information gain. You can select as many you want, but we are interested in ANOVA because we have performed ANOVA. And from this, we can understand if I'm clicking on ANOVA, I am getting in the descending order. The importance feature which is having higher value will be CP. Then we have seen that age is having less importance. 16.11 F measure was there. So it is having less importance as compared to the other features. While cholesterol was having 2.23. So it is having the least importance. It has no importance for calculating the heart disease. So what we can do, instead of taking all the 10 features for predicting the heart disease, we can only take 7 features or 8 features or whatever. Like if there are 1,000 features, you can select 50 features, first 50 features based on this analysis. So this analysis is for the feature importance. Okay. So ANOVA in case of machine learning is used for the feature importance. Well, in case of statistical analysis, it is used for hypothesis testing to understand which feature plays a role during data analysis, which data is more important. Okay. Now here, why I'm telling you both things together? Because I want to link statistics with machine learning. So these two terms are different. They are a bit different, but the things which we are doing is same. We are performing statistical analysis for hypothesis testing, and we are performing statistical analysis for feature importance. Okay. So this is about the feature importance. Now, next part that I want to show you, we are having only, okay, I will extend for 10 minutes. So I will complete this part, correlation. Okay, the correlation part. Now, next is, this was about feature importance. So this is the table that I got from the Orange data mining tool. Now, next is correlation. Now, correlation, what correlation gives? Correlation gives how two features are related to each other. Whether in case of this data set, in case of our heart disease data set, how age and sex are related with each other, how cholesterol is related with rest ECG, how age and target variable are related. So we are checking the correlation of the two variables. Okay, but to perform the correlation here, you have to, this is my SPSS. Okay, so first, let me explain you what is Persian correlation. There are 2 types of correlation, Persian, Spearman. But we are going for Persian correlation. I don't want to explain Spearman because we I want to explain you what correlation coefficient does and how you can compare the correlation and relationship between 2 features. So this is just the mathematical formula for it. You can understand. So just I want to explain what is the value you get in correlation and how you will predict the relationship strength. So Persian correlation ranges from +1 to -1, with +1 representing a positive correlation while -1 representing a negative correlation, and 0 represents no relation. The magnitude indicates the magnitude, this number, numeric value indicates the relationship strength, while the sign indicates the relationship direction. So if you are having negative, so it is negative relationship. If you are having positive value, it is a positive relationship. So depending upon the magnitude, what numerical value is there along with the sign, depending upon that, it indicates the relationship strength. Okay. Now, what is the importance of correlation matrix? So actually importance, as I told you, it is to check whether two variables or two features in the machine learn in our data set are related with each other or not. They are dependent on each other or not. Okay. So to check how the correlation, what is the correlation between two features? That's why we are calculating. Now I have, this is the screenshot of both the tools, Orange tool and SPSS tool. Just a second, excuse me. Okay, back. Okay, so we are having the Orange tool and SPSS tool. These are the correlation performed in Orange tool and SPSS. So I will go first into SPSS and tell you how to perform the correlation. So this is my SPSS screen. So go in analysis again, then you go in correlate. Now here I want to perform bivariate correlate. Bivariate means two features will be there. Okay, so bivariate correlation I'm going to perform. Now here there are three types of correlation: Spearman, Person, and Kendall's. So I am using Person correlation. Okay, so for Person correlation, which two variables you want to correlate? I want to correlate age with target variable. So one is age, other is my target variable. Okay, so I want to correlate with age and target variable and check. So here I got the correlation, Person correlation. Okay, so this is the value. Now I will explain you what it means. Okay, so this is the Person correlation of age, target, and REST ECG. So now here the correlation between REST ECG and target is 0.137, and between REST ECG and age is minus 0.116. Now, which value is greater? The value 0.137 is greater. Okay, while 116 is less. So REST ECG has highest correlation with target as compared to REST ECG and age. And this relationship is positive relationship because there is a positive sign. And here there is zero. Sorry, there is minus, that is negative. So it is having a negative relationship. Like if you want to check target with target variable, REST ECG age. So here minus 0.225. Minus 0.225. The magnitude is high. So it is having the highest, age is having the highest correlation with target, but it is in negative. Magnitude is high, but the direction is negative. So sign indicates whether it is creating a positive or negative impact. So like a negative sign means it is going in the negative direction. Positive signs means it's a positive relationship. So from this we can understand how two variables are correlated with each other. Similarly, in Orange tool, there is a correlation widget here. In case of unsupervised learning, you will find, so this is unsupervised learning, you will find correlation and you are selecting the columns for correlation. So this is the complete data that you can see. Okay, now here I have say I filter. I want all combinations. So it will give you all combinations, all values. So old peak with slope, age with Thalach, all the combinations are given here. Okay, so some values you can see having negative relation, some are having positive relation. So this is the correlation. And in this way, in both SPSS as well as in Orange, you can perform the correlation. Now, what is the use of correlation in case of machine learning? Now, in case of machine learning, if two variables are highly correlated with each other, then you can skip one. You can take one for training the machine learning models. You don't have to take both because they will create the same impact. Okay, like when there is very less correlation between the variables, you have to take both the variables because they both will take they both will create the different impact on the target variable, on predicting the target variable. Okay, so in this way, correlation and like ANOVA test that we have done, hypothesis ANOVA, that is feature importance. These two are pre-processing steps in case of machine learning algorithms. Before applying any machine learning algorithm, you have to first do the pre-processing of the data. Pre-processing means you have to select the features using feature importance techniques. You have to do the correlation of the data, how the data are correlated, to check which features we can, if two features are highly correlated, you can reject one, depending upon like which feature is having more importance on the target variable. So these things are important for the feature selection. So this is the process. Whatever I have told you today, this process is performed for the feature selection in case of machine learning. So this was all about the statistical analysis. If you want to understand the machine learning in Orange data mining tool, it will take more 15 to 20 minutes. So I don't know whether we can extend the session or not. So let me ask the permission. Host, can we extend the session for 15 minutes?
I don't think, ma'am, we can extend the session for
Okay.
15 minutes more. So it's a data hour, so it should be over in 1 hour.
Okay. Okay.
Yeah.
Sure. Okay. So like I will stop here because just I have completed whatever was aimed about statistics and machine learning link. So how statistical analysis and machine learning are linked together, and how statistics plays an important role in machine learning for feature selection, that I have explained you. Now, machine learning in Orange data mining tool, if you want the session, we can have the another sessions some other time. So I will stop here, and if you have any questions, you can post. I think you will have many questions because the session was a bit fast. I have to cover things. So like if you have any questions, you can ask me right now, or you can even mail me. I have my email ID is also given here on the slides. You can note it down, or you can contact me on LinkedIn.
So there are a few questions that are posted in question answer section.
Okay. Yeah.
So yeah, before we proceed to the question answer session, I'll just launch a feedback poll. So feedback polls help us to conduct more of the session and take the feedback of the session. So it will
Sure.
take just 2 seconds, and then we can move on to the
Yeah,
question
sure.
answer session. Yeah, okay. We can move to the question
Okay.
session.
So the first question, how to start a journey, or okay, that I will not answer here because that is going out of the scope. Then second is, what's the actual difference between machine learning and data science? So see, I have told you, data scientist, the one who is a data science, who is using a data science, or one who is a data scientist, have to use machine learning algorithms to analyze the data. So the machine learning is a part of data science, we can say. So the actual difference is, there is no actual difference from this diagram only. I have told you it is an intermediate between the two. Okay. So machine learning and statistics, there is intermediate. So machine learning is a part of data science. It is not a separate thing. Second thing, what is a bias error in case of machine learning algorithms? Like see, for bias error, you have to understand how the working of algorithms are, like especially in case of neural networks, how this error is propagated. This is very big topic. So I will not cover here what's a bias error. Next is, what is the data cleaning and data wrangling? Data cleaning means you are, like I told you, you are handling the missing values. You are handling the missing values by either taking some random value and posting there, or replacing it with a null value. Or you are removing the outliers, like as I told you, age. The age cannot be 500, so that is an outlier. And data wrangling means like playing with the data, performing various like dividing, like one type of data wrangling is dividing the data set into two parts, training and testing. Training part is given to the machine learning algorithms for learning the data, and testing part is given to for the prediction. So they both are nearly same, but some tasks are different between data cleaning and data wrangling. Then how we are entering into DL. Okay, DL, for DL, you have to understand ML. In ML, there is one algorithm known as neural networks, and deep learning, the basic of deep learning is a neural network. So all like deep neural networks, we will go from machine learning, then we go into the deep neural network. So it comes a DL. Then being a programmer, it is better to use SPSS or range tool instead of coding in Python. These are drag and drop tools. So being a fresher, to understand how the working is going on, to understand how machine learning algorithm works, how statistics works, you can go for these tools. But one thing I will tell you, many companies are using SPSS for their analysis. Orange is a data mining tool, while SPSS is a basic statistical tool. So many companies, marketing management companies, are using SPSS for their analysis. Even being a freelancer, I have worked on SPSS for 2 companies, and I have provided them the analysis on the base of SPSS. So like few companies work on SPSS also. So it is not like this programmer can only work on Python. Being a programmer, you can use, there are many languages. R is also a statistical language that you can go for. Okay, then next is, when input predictor variable are numerical, does it make sense to always do PC on predictor variable before doing any feature selection via ANOVA? PC is like a principal component analysis, which is feature reduction technique, not selection. Feature selection means you are removing few features and selecting few, while feature reduction means you are taking all 10 features, and from all the 10 features, you are just extracting new 3 features. Those will be 3 new features. So like ANOVA is a feature selection and PCA is a feature reduction technique. The next is, what happens in the ANOVA test? If one feature is only relevant under the condition of another feature, will the test rule this dependence out if you don't prepare the enough looking for that manually? Sorry, I didn't understood this questions of Johans. What happens in the ANOVA test if one feature is only relevant under the condition? Sorry, I didn't understood your question. Okay.
I don't think we'll be able to answer all the questions since we're already running out of time.
Okay.
So I think, yeah, we'll
So
have
you can
to.
send me your questions. So I will reply to you. I will try my best to reply to you.
Okay, so we'll end the session here. Thanks a lot, Priyanka, on the behalf of Analytics Vidya. I would like to thank you for your time and for delivering such a wonderful session. And I'm sure our audience found it insightful, and hopefully we can conduct more such session with you in the future.
Okay, thank you.
I
And
hope you guys. I hope you guys have, like, the audience have filled the poll. Uh,
yeah.
if you wish to conduct a webinar on or facing any difficulty in registering, we can connect with us at data@analyticsvidya.com. I'll just post the link in the chat real quick. Yeah, so the recording this session will be available within 2 days on our YouTube channel. I've already posted the link. I'll post it again. Yeah, Priyanka, you wanted to say something?
Yeah, thank you, participants, and thank you, like Analytics Vidya, for giving me an opportunity to deliver a session. That's all.
Thank you very much. We'll be back with another session of Data Hour on 17 January. That is tomorrow. The link is in the chat. Till then, take care.
Okay, bye. Take care.